This project investigates methods of presentation for tree stress, and climate data received from custom tree talker devices to communicate such data in a way non-experts can understand. Tree and forestry data understanding is poor, with 57% of UK respondents lacking knowledge on tree pests and diseases, just 27% being involved in forest issues in the past 12 months, and 22% believing that no action is required against climate change. Separately, 46% believed to have not perceived climate change, worryingly high given the extreme climatic events occurring. This project seeks to discover, can sonification, a form of auditory data presentation, and visualization approaches be applied to tree and climate data to raise public awareness of tree data and climate change. One work in this area is ClimaSynth, a web-based tool to improve climate change data accessibility using sonification and visual interaction. However, the sonification used only granular synthesis, and the lack of visualizations hinders visual learners or hearing impaired users. Trees presents the relationship between trees and climate change to the public through one sonification and visualization. Music and field recordings were played on ambisonics alongside real forest footage. However, the large on-site installation setup required restricts its access. A conversation between trees artistically presents climate change, focusing on HCI through abstract visualizations and spoken voice. However, it lacked numerical visualizations and sonifications, and its contemporary approach reduced widespread appeal. As one of the most important aspects of this project concerned identifying suitable data presentation methods, a participatory design user study was conducted, where 5 participants from a range of backgrounds including science, forestry, statistics, sonic and visual arts, and HCI completed a pre-survey and background interview to discover more about their ideas regarding tree and climate data presentation. Using these listed ideas, a set of features and a series of medium fidelity wireframes using Apple Keynote were produced, which was subsequently reviewed by the participants via a second survey. Using the participants' suggestions, the designs were refined prior to being implemented as a full-stack web application. The 5 participants were asked to review the tool both from a usability and data presentation aspect, before providing their opinions and feedback via a second interview and post-survey. A subsequent survey-based study was conducted, whereby a larger separate group of participants used the developed tool before providing their opinions, feedback, and insights gained after its use. The implemented tool is primarily developed using React, a front-end web application library, to provide excellent performance through minimized page re-rendering, with additional HTML, Bootstrap and custom CSS, and JavaScript. This uses an Express.js and Socket.io API, with endpoints to provide the appropriate data to view in the front end, with NodeMailer for email alerts for problematic data received from the Tree Talker devices, and handling of contact form information. Both run in Node.js, with the core application using the Web Audio API to generate the sonic output, D3.js, a powerful graphing library, to generate graph-based data presentations, and P5.js, a creative code and graphics library, to create interesting animations. Both front-end and back-end were developed using Visual Studio Code, and managed using a GitHub repository, which forms the basis for the front-end application deployment, which uses the free Cloudflare Pages service, and the API being hosted using Render, a low-cost Node.js hosting service. From the home page, let's go to the derived data presets. Let's view a line graph with accompanying drone sounds. Clicking on the tree icon displays more information about that specific tree selected. Clicking the About button provides more information on the mappings and the data used, while clicking the Help button provides more information on how to use the tool. Let's check out preset 2. Let's check out preset 3. Let's check out preset 4. Let's check out preset 5. Let's check out the personalized data feature. Let's investigate the source data. Source data gives direct access to the JSON files themselves from the endpoint, with some instructions on how to use the data. There's also a download of the JSON files directly for that use. Now let's look at About. So there's lots of different About sections to give extra information on the project. And we'll finally look at the Custom Audio feature. Custom Audio lets you create your own sonifications. So you first start by selecting the instrument type to use for each of the variables, and then you can make some further refinements to the instrument, such as the waveform type or the carrier waveform type used, and then you get to select some tonal adjustments, such as the vibrato depth on the synth. Then after that, you can set the playback speed in absolute or musical time, and then you can select the key signature for the overall piece, and the frequency ranges for non-musical instruments, and the note and octave ranges for the musical instruments that you've selected. After that, you can go to the next page, where you're enabled some playing roles if they're available, and then you've got the effects such as equalization, compression, distortion, delay, reverb, chorus, flanger, tremolo, and vibrato with all the controls there. You can set the spatial audio panning and the volume for the instrument and press play. A core challenge previously identified was how to improve tree, forestry, and climate change data dissemination through different data presentations to benefit understanding by non-experts. Instead of presenting only one sonification and visualization, this project seeks to reach a wider demographic through multiple different presentation approaches, alongside customization and interactivity through the personalization and custom audio functionality. This seeks to benefit engagement and data discovery through tailoring to a user's personal learning preference, particularly for neurodivergent learners or those with accessibility requirements, including visually or hearing impaired users, while promoting experiential learning. The tool seeks to provide an immersive and effective accessible experience, viewable from home on any standard computer or audio equipment, benefiting data democratization over the expensive, bulky, installation-based approaches. There's also a focus on graph and animation-based visualizations over contemporary approaches, alongside presenting raw data values, to benefit scientific and analytical thinkers, and appeal to wider demographics. After conducting a separate user study alongside the existing participatory design user study, 40% of study participants and 67% of evaluation study participants believed that their knowledge of tree data and climate change had increased. 33% of evaluation study participants believed that they perceived tree stress. However, 80% of full study participants and 67% of evaluation study participants believed that they might have perceived tree stress, and 20% of full study participants believed that they did not perceive tree stress at all. All study participants from across both studies believed that the customised and varied presentations benefited their understanding of the data. 80% of full study participants and 100% of evaluation study participants state that the study has inspired them to do something new in the future. 20% of full study participants state that the study might have inspired them to do something new in the future. 80% of full study participants and 33% of evaluation study participants noted some benefit and use cases for the interactive animation visualizations. 80% of full study participants appreciate the custom audio feature, with 60% of full study participants appreciating the personalized data feature. Thank you for watching, and please do visit the Dendrostream website to interact with the data yourself.